Hello, welcome to this episode of Manufacturing Matters, where we talk about the technologies and trends shaping the global manufacturing industry. I'm Aaron Hand with Tech B2B Marketing, here today at Automate with Ed Garstkiewicz from HARTING. Welcome, Ed.
Hi, Aaron. Thank you. Great to be here.
So, Ed, just to start us off, just give us a rundown of what HARTING does and what your role is there.
Okay, great. So HARTING is an interconnect manufacturer, connector manufacturer. We are an 80-year-old, 80 plus now, privately held company headquartered in Germany. We have 42 subsidiaries around the world and 14 different manufacturing locations. Really our focus is on connectors, interconnect solutions that solve problems for people that are rugged and reliable. My role with the company, I am a senior business development manager for emerging markets. So my focus is on industries, so our core industries, as you can imagine, being a German-based manufacturer for industrial products, tends to be manufacturing, industrial. We do a lot in rail, but certainly we are looking at other newer markets and emerging spaces, such as robotics, and a few others. So that's my role to focus and kind of bridge the gap, understand where our product fits within these markets, and then where we need to go, what products need to be developed to continue to support our customers.
Okay, great. So I think you said to me at one point, nobody designs a device around a connector.
That's right.
So I feel like that puts a lot of pressure on you then as a connector developer to design around what's already there or design for various environments.
Sure.
So talk a bit about that, about what kind of constraints that puts on you guys as developers.
Sure. And it would be really cool if people actually did design their products around, at least for us. But really, you need to understand, as a connector manufacturer, we need to understand the industry that we're selling into, what are their pain points, what are their challenges, and kind of think ahead of the things that they're going to want to address, whether it's a harsher environment, whether it's high shock and vibration, where is the product going to be used that will benefit their application. And really, I think that's one of the reasons there are so many different SKUs of connectors, because there are so many different problems to solve. So we do our best to anticipate where those problems will be.
Okay. So, you think about a lot of the buzzwords in the industry. You don't necessarily, again, you don't think about connectors first,
right.
But that doesn't mean that connectors aren't instrumental in a lot of those developments.
Sure.
So thinking about Industry 4.0, edge computing, just artificial intelligence and the data growth that the industry is seeing. So I guess talk a bit there about kind of the role that connectors play in a lot of these areas.
Right, and you mentioned the key word is data. So everything that we're doing, AI, smart manufacturing, predictive maintenance, all those things require information. They require data to make decisions. And connectors need to be able to support that. A lot of times these decisions need to be made very quickly in real time, literally. So that means more signal, higher bandwidth, there's more information. So that's one of the challenges that the connector has to address. The other is, generally speaking, the manufacturing floor footprint doesn't change, but we're requiring more information, more data. That means more sensors, more devices to maybe process that data. But we can't grow our manufacturing floor exponentially. So connectors have to find a way to process that information, but work within the given footprint for on the floor, for the devices, for the equipment.
Okay, so you're trying to send more data, more power, more, I'm not sure what else, through that connector, but the connectors can't just keep getting bigger and bigger,
correct.
Right? Is that the crux of the footprint issue?
That is one of the cruxes of the issue. Also, and we not only can they not get bigger, but connector is getting closer and closer to the edge. So the more information that we want to acquire, the more sensors, the more the more data. I guess it comes back down again to data. But a connector may be used when before it was in a control panel or a cabinet or a more or less benign environment. But now we want to have connections right at that point of the motor, and we want to have sensors right there, and we want to understand that. So now we're introducing more shock vibration, maybe temperature cycling. Maybe we're doing something that's automation now is moving off the manufacturing floor even and into other spaces like construction or agriculture. So the connector needs to survive in those areas as well. So really a lot of things to consider.
Okay, so I guess just thinking there a bit about construction or agriculture, you've got, it seems like everything would be multiplied in terms of vibration issues, right. Harsh environments. Right. I guess, can you talk about some of the things you're doing with the technology in order to survive those types of environments?
Yeah, that's a great question. So we are finding different ways, or we're developing different ways to help the connector survive. For example, on a printed circuit board connector, maybe we have surface mount connections, so we're not going through holes. We can have fixing or latching mechanisms to kind of keep the connector in place on the printed circuit board so it can withstand some of that shock and vibration. We're doing a lot with internal latching in different ways, and not just to withstand the environment, but also one of the benefits of connectivity and using connectors is the quick disconnect. So if there is a problem, then we don't want to have, hours, days of downtime to replace or rewire or do that. So we work on methods where the connector is really easy to install and really easy to replace when there is a problem in the field. Okay.
So you've got, you want it to stay when you want it to stay,
yes.
Regardless of whether it's, on a vehicle that's rolling along bumpy terrain.
Right.
But you want to be able to disconnect it quickly still.
Yes.
Right? So
yes.
Does that take some ingenuity there to come up with the right types of latches, or what? I'm not sure what would be used there.
Yeah, it takes quite a bit. The right type of latching, and there are different ways to do it. You can do it, with kind of the traditional circular bayonet style latching. I mentioned the internal latching with like a push-pull connector. And then what that means is instead of having an external latch where you have to crank it down and you maybe need that hand strength, you've got a latch basically inside of the hood, the housing that protects the electrical portion of the connector. And so then you just plug it in, and maybe you hear a little audible click or some indication that the connector's latched, and it's done. You know it's worked, you know it's latched, you know that connection is going to be reliable. So there's so many different, so it's really a balancing act, because you want, we talk about some of the trends for size and space, and we want our connectors to be smaller, but we want them to be more rugged, or rugged in applications maybe that they weren't originally designed for. So you really have to find a way to balance all of those elements.
Okay. I'm just thinking about all the various things that you got to come in way too often after the fact to make all of this work together. Right. Do you have customers who recognize that at this point, that it might be a good idea for them to bring you in sooner in these designs?
We do, and in a way that is how our business has evolved, is we prefer to partner up front with a customer, with someone designing a product, and we do that a lot more. So rather than just be, let's say, just a supplier where they're picking apart, from a digital catalog, we want to be a partner up front and help to design a solution that will, facilitate what they need to accomplish in their design. So I think that's really been a a big push, and that's helped us, to grow and to be more successful overall.
Okay. So I would like to get kind of back into, you had mentioned about like the increasing number of sensors, not just the number, but I guess the density of them too. So just lost my thought about where I was going with that. But part of, I just feel like there are different ways to come at this miniaturization question. So it's not just the connectors need to be smaller or something. I mean, I think with everything closer together too, I would think you'd have an issue with maybe data integrity, noise or crosstalk or whatever there might be. So can you talk a bit about what those technical trade-offs are that you guys have to deal with to make miniaturization work, I guess?
Right, that's a great question. And you're absolutely right. As we're making things smaller, we have the risk of interference and signal integrity. We're also talking about higher data rates, higher bandwidth. So that's a challenge, and we can address that in some really creative ways in terms of connector design. Potentially using even generative AI to consider and look at some of those challenges there. But we've got some really great signal integrity engineers who consider those kind of things. But also in terms of shielding, in terms of as things get smaller too, then we have an issue with handling the increase in temperature, so thermal management. So that's another area that we really have folks thinking about. Another way that you can miniaturize without necessarily making the connector itself smaller is by using a hybrid solution. So, typically, you may have an individual connector for control signal, for power, for pneumatics, for fiber optics, what have you. So you've got multiple different connection points, multiple different cable assemblies. So that's going to contribute to the size and overall footprint on the design. So maybe we look at a hybrid solution. Something where we're combining several of those modalities into one connector, and yes, and that's been an area of focus of ours for a long time, because that gives you the advantage of you've got the density advantage, you've got less weight, less cabling. We think about sustainability and some of those things, less material. So those are areas that we're also focusing very heavily in our design process. Then still, you have to be cognizant of as even in a hybrid connector, you could have interference between the connections. So we are definitely aware of that.
Okay. So I just wonder then, there's usually a trade-off. Okay, we can put these various functionalities, I guess, in one connector. Is there something that you're giving up in order to be able to do that? Or is there any risk?
Yeah, there's certainly there's some risk, and we talked about a little bit about the impact of the different kind of modalities inside a one connection point. If there's a failure in one cable in your power cable. If you're doing a hybrid system, then you've got to replace the power and the signal and everything else that's within that hybrid connector. So then it comes to thinking about how can we make this happen easily? How can we make this easy for the user? Are there options that we can do it all in the field? So when there is a problem, rather than have to have an electrician come and unwire and rewire a solution, maybe something's easy enough where this can rapidly be done in the field without having to involve other personnel. So yeah, they're constant. It's constant push-pull in terms of trade-offs, but we've got years, decades of experience in working in this kind of area. So I feel very confident that pulling in our experience and our expertise and working with the customers, we typically do a pretty good job of finding a solution.
Okay. So getting back to kind of the ruggedization question too, when I think of a rugged, whatever it is,
right.
whatever device or product, I think big, heavy stuff.
Yep.
But I'm assuming you still need to combine rugged with miniature in a lot of cases too. You talked about the connection of the connector, whether it's latches or whatever. There's that aspect, but are there other things that you're doing to say this is rugged, but that doesn't mean it's this big bulky thing?
Right. And that tends to be another challenge. It'd be much easier to throw a very large, safe package around this small connection point to make it super rugged and environmentally protected, but then that doesn't work in terms of real-world applications. So I think a good example of making something not bigger but still more rugged would be if we look at the RJ45 connector, for example. This is a connector that's used very heavily in industry, but was designed for office type applications. So It was not designed to be rugged. Initially, things that we did were to put more better packaging around the standard RJ45. You put a protective shell around it, maybe to make it IP rated so that you can use it in a harsher environment, or that it's better in terms of shock and vibration. So that's one way to do it, and we certainly have many solutions from going from that aspect. But another way, and this is something that we tend to do, is completely redesigning the connector. So we know what the function of the connector is supposed to be, but now let's redesign that connector in a more industrial form factor to begin with. So now we're not trying to make a commercial product more rugged. We're from the ground up building an industrial product. And when we do that, then we have the ability, technology has certainly changed a bit, and we have the ability to also hit that miniaturization aspect. Okay. So our product, the iX Industrial Connector, is maybe 70% the footprint of an RJ45, but it's completely industrial rated. It's it's got the shielding, it's got everything that you need for a more rugged environment, but also something smaller.
Okay. One thing I'd like to get into today are smart connectors.
Yeah.
So I've heard the term smart connectors. I really don't feel like I have an inkling of what that would mean. What is it? I mean, I guess first just give us a definition of what you would call a smart connector, and then let's get into what that means, what that enables.
Yeah, so I think a smart connector, very broadly defined, is, so the typical function of a connector basically is to provide electrical connection, power, signal, or data. That's the primary function of a connector. And what I would consider a smart connector is something that's adding additional intelligence or adding additional functionality beyond the kind of the basic use of a connector. And that could be anywhere from, let's say, adding a little LED status indicator so that the connector's plugged in and it's powered, so just to enhance that user experience. Or it could be adding some type of mechanical locking system so that you can't, when the equipment is powered and you can't unplug it and maybe accidentally electrocute yourself. So it's got that bit of intelligence.
Hey everybody, I just want to take a quick second and thank our sponsor. Manufacturing Matters is sponsored by Tech B2B Marketing. They're a full-service public relations and marketing agency that focuses on technology companies, especially in the energy and automation markets. They provide full-service media relations, investor relations, employee relations, full end-to-end content development, video services, animation, full IT stack development from website integrating with ERP systems, CRM, marketing automation systems, and they bring a whole lot of knowledge and experience about technical market since they've been servicing those markets for over 30 years. So if you have any questions, you want to learn more, go to techb2b.com. And now let's get back to the show.
So one of the things I had written down too was current monitoring.
Yep.
I mean, you have a connector that could monitor what's actually coming through?
Correct, and that's what I was going to say. So the kind of the addition of maybe ICs, sensors, and different things within that connector form factor package, so that the connector is essentially collecting information about the environment around it or about the equipment that it's connected to. So you could monitor, if there's spikes in current, or potentially you could monitor if there's rapid changes in temperature or the shock and vibration. So whatever kind of status indicators that you need to understand how your overall system is working. Adding some of that functionality to the connector now makes it levels up the connector, so to speak.
Okay. I think about like Industry 4.0, just putting a lot more sensors on things that can monitor vibration or heat or whatever might be an indicator that, say, a piece of equipment is going to fail.
Right.
So does it in this case then you're incorporating sensors into the connector?
Yeah, I mean, and that's a goal, and a lot of this is being worked on. Some things are here today, some things are still being developed, but yeah, that's absolutely the goal. So now we've got, maybe in conjunction with the connection to the sensor, now we see what's happening right at that point of the connection level, or maybe the information collected by the connector, maybe we don't need as many sensors at that endpoint because the connector is collecting that bit of information.
Okay.
An example of a smart connector today would be, we have a connector that, if you think about data centers and that area that's just exploding right now,
right.
Well, certainly HVAC systems and building management systems are an important piece of that. And as you know, how huge the data centers are, so the control systems for HVAC are getting larger, and they need a lot of fused terminal blocks for, because to prevent overcurrent or short circuits and things of that nature. Okay. What we've worked on is, instead of having the fuse inside of the cabinet that can only be accessed by a licensed electrician, for example, now let's put the fuse inside of a connector that's on the outside of the cabinet with a status indicator that shows you when that fuse is blown or when it's tripped. And so then you can maybe potentially just replace that fuse. You don't necessarily need to have a licensed electrician, and you don't need someone going into your cabinet, from a pure security aspect and from a time down aspect, from an efficiency standpoint.
Okay.
So yeah, that would be an example of a smart connector today.
Okay. And I would think that smart connectors could play into a lot of the edge devices or edge computing that seems to be growing in popularity.
Sure.
Also, are there opportunities there to maybe, I guess I think about incorporating the sensors into the connectors. Maybe there's other things that you can incorporate into those connectors to kind of reduce what you need at the edge?
Sure. If we think about increasing the intelligence, the processing capability in a connector, maybe we don't need as many edge devices. Maybe, at least that first level of collecting and processing information, maybe that's done strictly at the connector level. And then we've got less devices, and it's less weight, smaller footprint. So yeah, I could definitely envision an area like that where connectors can simplify, our push to smart manufacturing and IIoT.
Okay. Bring this into terms we can visualize. I mean, you talk about some of the things that you're doing now versus maybe some of the things that you're working on more for the future. Where are you seeing the need for this technology more? Like what types of industries, what types of environments do you see smart connectors making sense?
That's a great question. The generic answer would be all of them.
Of course.
Yes. Certainly I gave an example in the data center space because that's something that's expanding. I think in a manufacturing space, I would say mobile robotics. So a humanoid robot would be the perfect example for the need for smart connectivity because right now, I've seen numbers, and the wiring, the connectors, everything make up, 5 to 10% of the weight of a humanoid. Plus, you've got other systems, and it's very high-speed processing of data and information. So, if we're able to add functionality to the connector, and perhaps reduce the need for some other systems inside of the humanoid, we're lowering the weight. And where that is important is the efficiency of the humanoid robot. They're running on batteries, they're not wired. And so the longer the runtime of the machine, the more that we can get out of it. And so I think that's going to be a kind of critical point into the adoption of humanoids. The more we can do with it, then the more likely the humanoids are going to take off and be adopted.
Okay. Yeah, I think about robotics maybe putting a lot of pressure on the connector industry to develop what they need, but it sounds like there's a lot of opportunity too.
Right. There's both. And that's why it's important to be at events like Automate. And Automate has a humanoid robotic forum where manufacturers are there and having these types of discussions to understand what the needs are and what the challenges are and how we can address them.
Okay. Yep. I think we've kind of talked about some of the questions that I had planned. Mm-hmm. And I a lot with not necessarily, I think certainly an issue with humanoids, but I think AMRs in general, whatever sort of mobile robotics you have, is battery charging.
Yes.
How they're going to handle
yes.
the various, does it go back to this one station for X number of hours or how often do you have to charge those? Do you see like connectors being able to provide the capability of I guess monitoring that battery state?
Right. More of maybe the BMS battery management system functionality is incorporated into a connector. Maybe that's farther into the future, but even still collecting and providing some of that status information or looking at current draw, looking at different things. I think the connector can do that and help with that by incorporating more sensors and smarter connectivity. Certainly the connector, the miniaturization that we talked about would really be a key for enhancing battery life for an AMR or a humanoid. Right. By reducing weight. Shock and vibration is certainly is very, very much important. So we want rugged, reliable connections when we're talking about that. Then I think another area where connectors could play a role is one of the challenges I think with humanoid is what happens when something fails and how easy is it to replace a system or to replace an arm or the end effector or what doesn't work and perhaps connectors can play a role in making the humanoid more modular and easier to repair and then we keep it operating and running and everybody's making money and happy.
Okay, all right. Well, let's take a look at the future a little bit.
Sure.
We'll get it wrapped up here. I know you need to get back out on the show floor too.
Sure.
But let's take a little look 5 to 7 years. That's not very far out, but right. It's probably a lot can change in that time. Right. So where do you envision connectors going and the kind of role that they might be playing that people might not expect now?
Yeah, that's a really good question. I think we've touched on some of it, but the trends towards miniaturization, I see connectors continuing to get smaller. I mean, I know people are looking at some really, really interesting things in terms of packaging. I think connectors will be looking at different materials, to facilitate some of these things. Certainly, continuing to evolve in terms of adding intelligence, in terms of adding functionality to the connector. I think that's going to be a clear direction for the industry. Yeah, and then then of course the bandwidth and data rates and the things that we're doing. I've been in the industry for a number of years, and the things that we're able to do with copper connectors is just mind-blowing. We never thought we could get anywhere near the kind of data rates that we're doing. And I can't imagine in 5 to 10 years from now, if it continues with copper, maybe there's fiber optic as well. So I think all of these kind of mega trends, I think, will continue. And I really, really look forward to seeing what the next evolution is for connectors and long term and for the systems that the connectors support.
Okay, all right. Well, I appreciate you taking the time out of your day to talk with me, and thank you all for tuning in. And just keep in mind that we've got Manufacturing Matters podcasts showing anytime you want at manufacturing-matters.com. Or check us out on YouTube or whatever podcast platform. If you have any questions for Ed, you can put your comments below wherever you're watching, and just remember to stay tuned. Thank you.
All right, thank you.